All right, so this first question, it says the absolute extrema on a closed interval, so between -1 and 8. This function is continuous. It's all positive exponents here, no square roots. So it's defined on this whole interval, so it has an absolute max and an absolute min. They are going to occur either at the endpoints or the critical points. Right, so I start by finding the critical points. 8/3 x to the -2/3 minus 4/3 x to the 1/3. I'm going to rewrite that without negative exponents. And I notice that the bottom is 0 is undefined when x equals 0. So that is going to be one critical point. So I'm going to test -1. So that's an endpoint. I'm going to test 0. I'm going to test the other endpoint, g of 8. And then I'm going to maybe find another critical point or two here. I'm going to start by getting rid of the denominators. So I'm going to multiply everything by 3x to the 2/3. That's going to give me 8 minus 4x, right? Cleans up very nicely there when you clear the denominators. So x equals 2 is another critical point. The biggest of these is going to be the max. The smallest of these is going to be the minimum. And so here I just have to plug those values in and see what I get for each of those. So g of -1 is going to be -8 minus 1 is -9. G of 0 is 0. G of 8, the cube root of 8 is 2. So this is going to be 2 times 8 is 16. Minus 16, that's going to be 0 as well. And finally, g of 2. Not quite as nice there. 8 cube roots of 2 minus, this is going to be 2 cube roots of 2. So 6 cube roots of 2. The smallest of those is the minimum, the biggest is the maximum. This is the only positive value, so this is the maximum at 2. Let's just check that when I put in -1. Yeah, because it's minus, cube root of -1 is -1, but when I raise it to the 4th, that's going to give me a positive 1, so minus that. So -9. And that's the minimum. And that's our absolute maximum. Okay. So this is like the one we've done in class. This is the graph of the derivative. Do not confuse this with the function. F of x is decreasing where the derivative is negative. Right? The derivative is negative here and here. So those values are from -5 to -3 and 2 to 5. At what x value does my function have a relative maximum? That's where f prime of x changes from positive to negative. So that is going to be here. So at x equals -5. And let's see, positive, negative, that's here. And 2. Where is f prime of x concave up? That is where, or f of x concave up, that's where f double prime of x is less than 0, which implies f prime of x is decreasing. And I can see that it's decreasing from, oh, sorry, I was going concave down, but it's concave up. So I gotta switch these, right? Bigger than 0 and increasing. So that's going to be from here to here. So I'd say -4 to -1/2. Any kind of estimate is okay. And it looks like there, 4 to infinity. Okay. Sorry, I was writing off the screen there, but just as well because I made that little error, increasing versus decreasing. Okay. So, does the mean value theorem apply? In order for the mean value theorem to apply, f of x must be continuous on the interval -1 to 3 and differentiable on the interval -1 to 3. So, it is continuous. The cube root, you can take the cube root of any one of those values and you still get a value, and let's look at its derivative, 1/3 x to the -2/3, which is 1/3 x to the 2/3, and we see that has got a problem at 0. At x equals 0, that's undefined. That implies it is not differentiable. Mean value theorem does not apply, because that is in my interval. Again, if my interval was 1 to 3, then that's fine. Right? I only care about if it's differentiable inside that interval, but this is not, because 0 is in that interval. Alright, so number 4. Find the intervals where the function is increasing. So I look at its derivative. 15x squared minus 15x to the 4th, which is 15x squared times 1 minus x squared, or 15x squared times 1 minus x, 1 plus x. So I see I have 3 critical values at 0, 1, and -1. So my intervals here go from -1, minus infinity to -1, -1 to 0, 0 to 1, and 1 to infinity. So if I pick some test values in here, and I look at the sign of the first derivative, if I made a slight error here with these values that I wrote down here. When I put in -5, this part is always positive, so I don't have to worry about that, but it's 1 minus x. When I put in -5, this becomes positive and this becomes negative, because I'm adding a 5 there and subtracting 5 there. So this is actually switches all of these. That's a negative, positive, and negative. So when I put in -1/2, and it can be easier to do it in the factored form. Sometimes it's easier to do it in this original form, but when I put in -1/2, that's going to make this a positive 3/2 and this a 1/2. So those are all going to be positive there. Same thing for 1/2, and again 1 minus x. So it's from -1 to 0, union 0 to 1. And once you have that information, you do know the relative extrema too, right? Because it goes from decreasing to increasing, and here it goes from increasing to decreasing. So f of -1 is going to be a relative minimum, and f of 1 is going to be a relative maximum. Okay, so concavity, I'm going to look at the second derivative. That's going to be 30x minus 60x cubed. So that's 30x times 1 minus 2x squared. So I get x equals 0, and 1 minus 2x squared equals 0, so 2x squared equals 1. X equals plus or minus the square root of 1/2. Don't forget both of those. So I've got a fair number of potential inflection points here. Minus the square root of 1/2, 0, and the square root of 1/2. Make sure you don't miss anything. And then here I put in my test values again, -5. I want to pick something pretty close to 0, so square root of 1/2, I got to make sure I'm not, the number I pick isn't on the wrong side of that. But 0.1 should work. Square root of 1/4, it's actually bigger, or sorry, square root of 1/2 is actually bigger than 1/2. Sorry about that. Again, I worked off my page here. A little rough on this, but so then I test. A large negative value is going to make this negative and this negative, so that would be positive. A small, a negative value close to 0 is going to make this piece small, so it's just going to end up being positive, and this is going to be a negative. So that's going to be negative on this interval, positive over here, right? Negative there, positive there, and negative there. You also know it switches at each one because the multiplicity of each of these zeros is 1. That's another way of kind of analyzing what's going on. So concave down are going to be these negative intervals from minus the square root of 1/2 to 0, union square root of 1/2 to infinity. Okay, well, I hope that was helpful. Obviously there's some small mistakes that can be made, right? And I do understand those. But you got to show your work, right? If you just give me the wrong intervals, then I don't know what the mistakes were, right? Were they a substantial mistake where you weren't looking at things, or was it a sort of trivial mistake where you just flipped a sign accidentally? Right? So those obviously would get treated different ways, but you got to show me the work so that I can tell which of those you are doing. All right, happy studying.